set of all points in a plane that are a given distance from a fixed point called a center. All right. Circles are usually named by their centers. So we would call this one circle P.
Wait, would it be their centers or their center?
Well, since I have circles, centers. But if I had a circle, it would be its center.
Okay.
So,
Flora.
you draw the circle with the dot in the middle?
Yeah, I was about to say that with
Yes, would be the symbol for a circle.
the. Why?
Because that's a circle with a center, and we call it circle P. That way, I mean, you can write out circle P, but you can also just use the circle to name circle P. Just to save you from having to write out circle.
So you don't need the dot.
He said P-O pause that.
Put the dot.
Do you necessarily need it though?
Yes, put the dot. What are you doing, William?
This wall is really disgusting.
Talking about the radius of a circle, the plural is radii. So if you see radii, that's the plural of the radius. This is a segment whose endpoints are the center of the circle and a point on the circle. A segment whose endpoints are the center of a circle and a point on the circle.
What does that say? Oh, and a point.
Okay, a segment whose endpoints are the center of the circle and a point on the circle.
Good magic trick.
Okay. A chord is a segment whose endpoints are on the circle. So if we wanted to name a chord in the circle that I have, what would be one chord on the circle C? Lauren? Chord AB. Do we have any other chords? William? Chord EF. Any other chords? Do I have, what's a radius of the circle? Chloe? CD? Do we have any other radii of the circle?
CB is in the thing.
CF is a radius of the circle. Any other radii of the circle? CE. The diameter of a circle is a chord which contains the center of the circle. A chord which contains the center of a circle. All right, so what are some diameters that we have for this circle, or a diameter or diameters? Flora?
FE.
FE. Any other diameters of this circle that are shown?
Will the CD count? Because it only goes halfway.
So,
No.
Well, it
What's-
contains the center.
is it a chord?
That's a radius.
Never mind.
Okay, good question. No, and is there only one diameter for this circle?
Sometimes.
Yes.
No, they're infinite.
I'm hearing,
For this circle.
I have one shown. Are there more?
They're infinite.
Yeah,
more.
there are more.
There are more. I only have one diameter shown. So, but you could draw several different diameters. It's a chord that goes through the center of the circle. Let's look at the next page. Oops. All right, from the definition of a circle, we know a couple of things. What could you conclude from the definition of a circle about the radii of a circle?
It's half the diameter.
It's half the diameter. What about all the radii of one circle? What could you conclude about that? Anything, Haley? They're all congruent. All radii of a circle are congruent. All radii of a circle are congruent. What about the diameters of a circle? All diameters of a circle are congruent. Okay, now there's a formula for the diameter, which you probably already know, but it is twice the radius. And so real often you see the diameter is 2r. If you know the radius, you can easily find the diameter. Okay, now a circle can separate a plane into three different parts. We have the interior,
Is this coming out? Figure it out.
interior of a circle. Which point is located in the interior? Point I is in the interior. We have the exterior of the circle. So what point's in the exterior of the circle?
Wait, I is the interior.
Is in the interior
What would be E?
of the circle.
I think it's T. I think it's
E.
E is in the exterior of the circle. Or is exterior to the circle. And then we have the circle itself. Are there any points on the circle itself?
T.
Okay. And so T is on the circle itself. So a circle separates a plane into three different areas or three parts: the interior, the exterior, and the circle itself. A tangent to a circle is not the same as a tangent of an angle of a right triangle. A tangent line to a circle,
Tangent just means
is-
like circularly? Like
No.
the word itself?
no, a tangent to a circle is a line that intersects the circle in exactly one point. A tangent to a circle is a line that intersects the circle.
I know it.
In exactly one point.
Why is this not blue? I died. I think you guys should pay attention.
A tangent to a circle is a line that intersects the circle in exactly one point. That point is called the point of tangency. So what's the point of tangency in the drawing that I have there? X is the point of tangency. Okay? So line L is tangent to circle P at point X. Now we'll be dealing, when you get to calculus, you'll be dealing with tangents a lot. So a tangent to a circle is a line that intersects a circle in exactly one point. Now, the other picture shows us a secant. And a secant is a line that intersects a circle in exactly 2 points. Would it be possible for a line to intersect a circle in more than 2 points? Yes, no?
No.
Why not, Hannah?
Because like.
That was not mine.
Kevin, is your phone turning off or on? Samsung tend to like turn off and on at random. Yeah.
Oh, okay.
I don't know.
Lauren, why can't it only intersect in 2 points?
Because it can only go straight across. There are only 2 parts of the circle can intersect.
Okay. Can't turn back, and if we had something that wasn't a line, it could come back and intersect again. But a line can only intersect a circle in 2 points. And that line contains a chord of the circle. So we have a chord AB, but line AB is a secant to the circle.
Unnecessary.
Okay, so line AB is a secant to circle C. So there's a difference between a tangent and a secant. We use both of those ideas in calculus, but you will continue to see tangent lines and secant lines. All right, a common tangent's a line that's tangent to 2 circles at the same time. A line that's tangent to 2 circles at the same time. Okay, we have 2 types of common tangents. The first one you see there is a common external tangent.
I'm so not mathematically inclined. I wrote 2 GWO and then circles the word.
Doesn't matter.
It's
I
just
wrote
words.
tangential.
Okay, a common external tangent is a common tangent that does not intersect the segments whose endpoints are the centers of the circle.
And it's bread. There's fire underneath the 6. The dragon's coming up.
William,
I didn't realize she's recording for her other geometry class.
okay. A common tangent that does not intersect the segment whose endpoints are the centers of the circle. In other words, a common external tangent is not going to intersect this segment. A common internal tangent, notice this is a common tangent that intersects the center, the segment whose endpoints are the center. So this one does intersect the segment whose endpoints are the center. It's a common tangent that intersects the segment Yes.
Homework? That's due to next next class, are we supposed to finish the worksheet?
Yes.
Most people need to go.
Particular picture of the common internal tangents, line S and T are common internal tangents to these two circles. Line S and T are common internal tangents. This is an S, yes.
I have an extra one.
Okay.
Whose endpoints what?
Are the centers of the circle.
Whose endpoints what?
All right? Concentric circles are two or more coplanar circles that have the same center. Two or more coplanar circles that have the same center. And congruent circles, if we're going to come up with a definition for congruent circles, we could say that congruent circles have congruent radii. If two circles are congruent, that means that the measure of each radius is the same.
Wait,
Congruent circles have congruent radii. So if you're told that two circles have the same radius measure, you know those are congruent circles. All right. When two coplanar circles are tangent to one line at one point, the circles are tangent to each other. You have external tangents and you have internal tangent circles.
find congruent circles.
They have congruent radii.
That's their definition.
That's it, that's a definition.
Oh, I
Con-
thought that was
con-
part of the concept.
So when two coplanar circles are tangent to one line at one point, William, the circles are tangent to each other. Two options here. Externally tangent, that means that the centers of the tangent lines lie on opposite sides of the tangent. Notice with circle M and N, the centers of the tangent line lie on opposite sides of the tangent. All right, centers of the circles lie on opposite sides of the tangent line. We also have internally tangent circles. The centers lie on the same side of the common tangent. The centers lie on the same side. Of the common tangent. About it. A polygon is circumscribed about a circle. Circumscribed is on the outside. The circle is inscribed in the polygon when each side of the polygon is tangent to the circle. When each side of the polygon is tangent to the circle. Inscribed inside. Here the circle is inscribed inside of that triangle.
Who else saw it as the Deathly Hallows symbol?
Me. What? I did draw the line.
All right, the polygon, in this case, the circle is inscribed in the triangle. The triangle is circumscribed about the polygon. Notice these sides of the polygon, this triangle, are tangent to the circle. It just touches the circle at one point. Now, a polygon is inscribed in a circle, and the circle is circumscribed about the polygon when each vertex of the polygon lies on the circle. Okay, notice here that quadrilateral is inscribed in the circle because each vertex lies on the circle. These are the vertices of this particular quadrilateral. Pardon?
Those are just chords.
That form a polygon, yes. And those are chords of the circle. So the circle is circumscribed about the polygon. Or we could say that the polygon is inscribed in the circle. Central angle. That's one of the definitions we need to talk about. A central angle is an angle whose vertex is at the center of the circle. What could we say about the sides of that central angle, do you think? I didn't draw a circle here, but if this is a central angle, what could you say about the sides of that central angle? Haley? Good. The sides of a central angle contain radii of the circle.
Does that say central?
Mm-hmm.
Okay. I thought that said lateral.
Okay, the sides of a central angle contain radii of the circle. Now, a central angle cuts a circle into arcs. And an arc is 2 points on a circle and the continuous part of the circle between them. If we look at this little circle that I drew, the arc between the sides of the central angle would be right here. That's the arc. 2 points on a circle and the continuous part of the circle between them.
Can I get the towel?
Hang on just one second. Intercepted arc is an arc that is in the interior of an angle, I'm sorry. An arc in the interior of an angle. The arc that I highlighted in the previous circle is an intercepted arc. We could also say that this is an arc, but it's not an intercepted arc. An intercepted arc is an arc that is in the interior of an angle. This would be your intercepted arc. Then we have some different kinds of arcs. We have a minor arc, which is an arc whose measure is between 0 and 180 degrees. Okay, a minor arc is an arc whose measure is between 0 and 180 degrees. It is an arc that lies in the interior of a central angle. It's also an arc that lies in the interior of a central angle.
Does that mean that every arc is a minor arc?
No.
Or else there wouldn't be major arcs, which is the next definition.
A minor arc is an intercepted arc.
It lies between 0 and 180, and the circle that I drew up there, the red is a minor arc. It's between 0 and 80, and it lies in the interior of a central angle.
Why do you have two definitions for the same exact arc?
Because it can be defined in those two ways. Major arc is an arc whose measures between 180 and 360.
Then what's a 180?
180 degrees is like a line. It would be a semicircle. And it's an arc whose measure is between 180 degrees and 360 degrees. One complete circle, a circle has a measure of 360 degrees. All the way around is 360 degrees. And it's also, could be said, it's an arc that lies in the exterior of a central angle.
And if it's exactly 180, then is it a minor arc or a major arc?
It's a semicircle.
We just say that.
Oh, okay, I'm sorry.
Okay, a major arc, an arc whose measure is between 180 degrees and 360. It's an arc that lies in the exterior of a central angle. And a semicircle is an arc whose endpoints are the endpoints of a diameter. It also measures 180 degrees. It's an arc whose endpoints are the endpoints of the diameter. Is the arc addition postulate.
Just to indicate in case no one here said on the recording that was close based on that.
We had a segment addition postulate, we had an angle addition postulate, and now we have an arc addition postulate. And this says that the measure of a central angle is equal to the measure of its intercepted arc. So if you know what the measure of the central angle is, the measure of the intercepted arc is the same thing. All right, so arcs are measured by their corresponding central angles. This next one is the arc addition postulate. Notice when we name an arc, put a little arc symbol above it. But the arc addition postulate says that if the intersection of arcs DE and arc EF of a circle is a single point E, and in other words, they only have one point in common, then the measure of arc DE plus the measure of arc EF is equal to the measure of arc DEF. Sometimes, normally, 3 letters are reserved for a major arc. If it's a minor arc, we probably would just name it arc DF. So this could also be the measure of arc DF. If you use 3 letters, that usually is indicating that you have a major arc. And a major arc is what kind of an arc, Charlie?
It is, that's the 80 to 100, or 180 to 360.
Okay, it measures more than 180 degrees. Okay, so let's look at the circle I have drawn here. If we wanted to, what is the measure of arc DE?
100. Wait, no, 140.
I think, okay, and how did you get 140?
70 plus 70.
Okay, here the measure of arc DE is 140 degrees. And is that a major arc or a minor arc? It's a minor arc. What about arc DG? What kind of arc is that? It's a semicircle. Notice its endpoints are the endpoints of a diameter.
So that's 180.
And the measure of arc DG is 180 degrees. And we could either go this way with it, or we could go this way with it. What is the measure of arc, or what is kind of arc is arc DGE? Now, if I say DGE, that means G is in the middle. So if we're looking at arc DGE, that means that we're going to be going this way.
200 degrees.
180 plus 40.
220.
And what kind of arc would we call that?
Major.
It's a major arc. So it does make a difference. If you've got a middle letter, that's going to be the second. You start at D, you go to G, and then you end up at E. So that tells us that we have a major arc. I mentioned earlier that each circle is made up of 360 degrees. What here is the measure of arc PQ? Hannah? Here's my Q. What's the measure of arc PQ? What's the measure of the central angle? So what's the measure of the arc? 110.
These are not drawn scale.
No, they're not drawn to scale. What is the measure of arc QR, Kaylin?
QR is 120.
120 degrees. What is the measure of arc PQR, Nahom?
Is it adding them together?
Mhm.
Okay, so 230.
230 degrees. And what is the measure of arc PR? How would you find the measure of arc PR, Haley?
Subtract 230 from 360.
360 minus 230, so that equals 130 degrees. Good. All right. Okay, AC is a diameter of circle P. We know that AC is the diameter of the circle. I'm telling you that. It's a chord that goes through the center of the circle, so we know that it's a diameter. So we want to find the measure of arc BC. Charlie, what's the measure of arc BC?
30 degrees.
30 degrees. What is the measure of arc CAB, Flora?
330 degrees.
And how did you get 330 degrees?
Because 360 minus 30 is 330.
We could do 360 minus 30. Or another way you could think of it is 180 degrees plus 150. Because, yeah, that'll do it. So either way, I kind of like subtracting from 360, but sometimes one way may be more obvious to you than it is to me. What is the measure of arc ABC, Paige?
Did you say ABC?
Measure of arc ABC,
180.
180 degrees. What is the measure of arc AC, Kat? 180 degrees. So the difference here is if we're saying just arc AC, we're going this way. If we're saying arc ABC, we're going this way. But either way, you end up at the same spot. What is the measure of arc BCA? Haley?
210 degrees.
And how did you get that?
180 plus 30.
Okay, 180 plus 30 is 210 degrees. I have loaded these all up on RenWeb. It will need to go in your note card section at some point, probably after next class, I'll have y'all do note cards. But Theorem 9.1 says that in the same circle or in congruent circles, two central angles are congruent if and only if their arcs are congruent. So it's telling us that congruent central angles means we have congruent arcs if two circles are congruent, or if it's in the same circle. Or that congruent arcs mean that we have congruent central angles.